Good evening to everyone. On behalf of Meritnation, I welcome all of you to the session of NEET Bytes. So, here we are discussing electromagnetic induction. So, hello, dear students. So, today we'll take up some of the questions of NEET from electromagnetic induction. Let's move forward. So, first question. As a result of change in magnetic flux linked to the closed loop shown in the figure, an EMF is induced in the loop. The work done in taking a charge q coulomb once along the loop is, we have to find the work done in taking q amount of charge through the loop. Why? Because of change in magnetic flux. First of all, you should understand that whenever there is change in magnetic flux, an EMF will be induced in the closed loop. So as the EMF is induced, we can say that what is EMF? What is EMF? EMF is the amount of work done upon charge. Or we can say the amount of work done in moving unit amount of charge through the loop is the EMF, right? So we can say that the work done will be equal to Q times E, where E is the EMF induced. So in the given question, we can see that that EMF induced is V volts. So W is equal to Q into capital V. So that is the answer for the given question. So the correct answer for the given question is A. Let's move forward to the next question. Yes, what is the question? Let us read the question first. In the circuit of figure of the as shown in the figure, the bulb will become suddenly bright if contact is made or broken, contact is made, contact is broken, or won't become bright at all. So if you observe this, here we have an inductor. Okay, here we have an inductor. An inductor has a property to oppose the change in current. As you have learned that E, that means EMF induced across an inductor, is given by this formula. It's minus of L di over dt. So L di by dt is the EMF induced. So L di by dt. So if the current is increasing, EMF is in opposite direction to decrease this increasing current. If the current is decreasing, EMF is in such a direction that it will support the current. Okay, it will support the current. So if you observe the options, when we make the contact, in that situation, what happens actually? The current is increasing. The current in this direction is increasing. So as the current is increasing, an EMF will be induced such that it will oppose. That means this will become your plus and this will become minus to oppose this. Okay, so in that situation the current will become lesser as compared to the current that will flow without this inductor. So when the contact is made, we cannot say that the bulb will glow brighter. But when the contact is broken, in that situation, the EMF induced will support the current. See, when you break the contact, what happens? So suppose steady amount of current I was flowing in the circuit. Okay. So as you broke the contact, an EMF will be induced such that it will support the current. It will support the current. So in that situation, the current increases. The current increases. So that's why we can say when the current is broken, the bulb will become brighter because the intensity of the bulb is directly proportional to I. Yes, we have learned that H is equal to I square RT. So more the value of current, more the heat and more the glow of the bulb. Okay. Let's move forward to the next question. In an inductor of self-inductance L equal to millihenry, current changes with time according to the relation I is equal to T square into e raised to minus T. At what time EMF is 0? So very simple. We have to apply the formula. What is the formula for EMF? E is equal to minus L di over dt. Apply this formula. So yes, E is equal to minus of L into d by dt of t square into e to the power minus t. So when you differentiate this, what do you get? You get E is equal to minus of L into minus t square e to the power of minus t plus 2t e to the power of minus t. And that's equal, and we have to find when we have to find when the current when the EMF becomes 0. So substituting it to be 0. So what do you get? What do you get from here? If you take e raised to minus t common, and t you get minus t square plus 2t is equal to 0. Obviously, this cannot become 0 because it's a positive value. It will give some positive value. So minus t square plus 2t. Minus t square plus 2t. So if you take minus t common, you get t minus 2 is equal to 0. This implies t equal to 0 and t equal to 2 seconds. So from the given options, only the second option is there. That means t equal to 2 seconds is there. So that's why the correct answer of the question is C. Let's move to the next question. In a coil of resistance 10 ohm, the induced current developed by changing magnetic flux through it is shown in the figure as a function of time. The magnitude of change in flux through the coil in Weber is. So if everything is given in SI systems, or we have SI unit of current here, SI unit of time here, so whatever magnetic flux we'll get, it will also be in SI unit, that means in Weber. Okay. Now, if you recall, I is equal to, or just simply say, the EMF induced in a coil is given as if you talk about magnitude only, it will be equal to d phi over dt. And if you want to find the current is given by simply E by R. So 1 by R into d phi by dt. So now if you observe this equation, I is equal to 1 by R into d phi over dt. So d phi over dt can be written, or you can say d phi over R can be written as I into dt. If I have to find the total change in magnetic flux, I need to take d phi, R in the right and left hand side. So R into I into dt. So now integrate both sides. If you integrate both sides, what do you get? This is the total charge. Okay. And that is the area of the curve, that or area of triangle that you can see here. This area will give us the charge, total charge. Okay. So how can you find this area? Simply 1 by 2 times 4 into 0.1. So that's equal to 0.2, 0.2 coulombs. This is the charge. So R is what? 10, and this is 0.2. So when you multiply, the total change in magnetic flux is equal to 2 Webers. So the correct answer for the given question is B. Let's move to the next question. A conducting square frame of side A and a long straight wire carrying current I. So if you observe this, the long straight wire, according to the question, long straight wire means it's an infinitely long straight wire. Okay. Okay, so yeah, long straight wire carrying current I are located in the same plane as shown in the figure. The frame moves to the right with a constant velocity v. The EMF induced in the frame will be proportional to. We have to find the EMF induced in the frame. Okay. So how can we find that? If you observe, let us say the side is, sorry, this vertex is A, this is B, this is C, and this is D. So if you observe this, that we can find the EMF induced across AB and CD. How can we find that? Simply, we know the formula E is given as BLV, right? BLV. When, now you can see here that L is the length of this, that's A, the length A. So what is the value of velocity? V. So what is the magnitude of, you say, magnetic field across AB? You can see that across AB, the magnetic field is given by this formula, because you know it's an infinite wire. So the formula is mu naught I by 2 pi r. Mu naught I by 2 pi r is the magnetic field. So from this, if you want to find the magnetic field, across AB, so what is given over here? It is given that from the midpoint, or from the middle of this loop, the distance is x. So firstly, find this distance between the wire and side AB. So this is, if this is completely, this complete is A, we can say this one is A by 2. So this becomes X minus A by 2. And if you talk about the other side, that is CD, the distance is X plus A by 2, because this distance is also, because see, X is from the middle of the coil, and CD, the half of this is A by 2. Yes. So yeah, now we can find the magnetic field across AB and CD. Yes, very good, Meghna. So yes, B at AB is simply mu naught I, or it's capital I, 2 pi into X minus A by 2. And if you talk about E across AB, it will be equal to mu naught I divided by 2 pi into X minus A by 2 multiplied by V into L. Similarly, we can write E for side CD also. It will be equal to mu naught I over 2 pi into X plus A by 2 into V into L. Yeah, the length is equal to A because it's a square. So V into A. So the EMF induced over the coil can be written as E net is equal to EAB minus ECD. So by that, we can say E net is equal to mu naught I over 2 pi into X minus A by 2 minus of mu naught I over 2 pi into X plus A by 2. So you can just take mu naught I and 2 pi common. So you get 1 by X minus A by 2. Yeah, V and A are also there. VA and VA, right? VA also minus 1 by X plus A by 2. So now you can say VA into mu naught I over 2 pi and 2 X minus A minus 2 over 2X plus A. And if you further solve it, you'll get it 2X minus A into 2X plus A as the LCM. And 2 you can take common. So you can say VA into mu naught I divided by pi and 2X plus A minus 2X plus A. So ultimately, X and X get cancelled out. 2X get cancelled out. So we get, and we get the EMF induced to be equal to VA square by pi into mu naught I into 1 by 2X minus A into 2X plus A. So if you observe that E, that means E net is proportional to 1 by 2X minus A into 2X plus A. Okay. So the correct answer for the given question is C. So I hope you were able to understand. So thank you so much, students, for watching the session. So to know more how we can help you, you can see the given link. Okay. So thank you so much, everyone. All the very best for your NEET preparations. Solve more questions like this.